Welcome! This video introduces the idea of assembly languages and shows how we can explore this concept in the little man computer. So, up till now, we've used machine code for the little man computer. Machine code are the only kind of instructions that a computer can actually run. Right? In a real machine, of course, these would be binary instructions, ones and zeros. And this kind of coding has a lot of disadvantages for humans. Right? We have to remember the special opcodes, what each of these symbols mean. We have to manually figure out where in memory I want to put something. So I am trying to store a value to location 7 and then later subtract it. I have to kind of plan out exactly the numeric address where that piece of memory is going to be. What if I go through all that work and then realize I need to modify my program? I need to add some lines of code right here in the middle of my program. So I just slide everything down a little bit so I can type my new code in like that. Well, I've just broken the entire program. Right? My code here expects lines 6 and 7 to contain these pieces of information, and because I've scooted those down, now there's something else there. Right? So it's both cumbersome to write in the first place and really cumbersome to maintain this style of code where we're explicitly talking about memory locations. So assembly code is designed to make both of these tasks easier. Instead of writing out the actual numbers the computer is going to run, we're going to write human-readable identifiers that can just get translated. If I type load, that means 001. If I type store, that means 010. And instead of trying to remember exact locations in memory, we're going to be able to talk about them in a more abstract way. For the little man computer, here is what our assembly language looks like. This column right here. It describes for every machine instruction an equivalent assembly instruction. Instead of saying 104 to add something, I can say add blank, add first. Right? And we will create a program that can turn this assembly code, this more or less human-readable code, into the numbers the computer actually wants. Now, there are a couple new tricks. So the first is we've got this new instruction, dat. Dat simply indicates this is going to be a piece of information in memory, a piece of data. All right, so dat 10 means put a 10 in memory. Dat 0 means put a 0 in memory. You'll notice that before dat, there are these other words, 10 and first. Those are identifiers. Those simply label the line. 10 means that anytime we talk about the word 10, we mean line 6. First means that anytime we talk about the word first, we're talking about line 7. And that way we don't have to talk about line 6 and line 7. We can say, oh, that place called 10, that place called first. Right? So we don't have to, when I say store to location 7, I don't actually have to know that it's location 7. I just say store to the location called first. And the assembler, the program that's going to take our assembly and turn it into machine code, will do the work of figuring out that 07 is where the first is, and so store first should be 307. We can label any line with an identifier. Now, certainly pieces of information, these storage locations, pretty much always are going to have an identifier. We can also use identifiers to identify the targets of branches. Right? So in this assembly code, we're going to load from address 0, which is going to bring a 0 into memory, into the accumulator. And then the next instruction says loop start add 1. The assembler is going to look at that and say, well, loop start, that's not an instruction, so that must just be the name of this line. Add, oh, that's the actual instruction, location 1. So it's going to add the value that we find down here at location 1, which is memory address 6, it's going to add that 1 to the accumulator. Then we're going to do the output instruction, and then we're going to branch always to the place called loop start, which will take us back here. All right, so nowhere in this program do we have to use memory locations to refer to either pieces of data or to other instructions. And this solves the problem of being able to easily modify our program, because if I'm referring to this location as first instead of location 7 or location 9, even if I insert some extra lines in here and the place that used to be called first was at memory location 7 and is now at memory location 9, it's not going to matter, because when we assemble this program, the assembler is going to go through and figure out, first is now down here at 9, and so this should really say 209. This should say 309, and automatically adjust that. So the tool that we have to experiment with this is this web-based assembler. When you load the assembler, it will start off with a little program, and if you hit the assemble code button, it'll take that and produce machine code that you can copy and paste into the little man computer workbook. So I can paste that, and here is a program that I can go ahead and run. So if I step through this, I can see it takes in two numbers and it outputs their sum. Right, very simple program. Here is the assembly code for that program. INP input, so that's instruction 901. Store first, STA is store, so that's going to be a 300 instruction. And then to figure out location 6, what the assembler has done is it's gone through and looked for where first is, where that identifier is. Now, the first instruction is address 0 in memory, so 0, 1, 2, 3, 4, 5, 6. So the assembler went through before it tried to actually build the code and found that first was memory location 6, and so it went ahead, and anytime we say first now, it's using 6, 306. Add first. Well, that's add instruction is 100, and then memory location 6. Our output is 902, halt, HLT, ends the program. And that last thing, first is a piece of data. We didn't actually give it a value because we're really just going to use this as a storage location for the input. It would be the same thing if I started with 0. It would just show me a plain 0 there. If I wanted to have it start with the number 12 for some reason, I could do that as well. Now, if my identifiers don't match, right, say I do that and I try and assemble the code, it's going to tell me there's an error. It doesn't know what FASDF is. It's never heard of that identifier. Right, so I have to make sure that when I refer to something like first, it actually matches an identifier in the program before this will work. Right, and if I want to modify this, so let's add a couple copies of the first number. Right, I don't have to worry about adjusting any of the memory addresses. I can just copy and paste that line of code in, and when I assemble it, now first is further down in memory, so it's at location 9, so all those places that refer to the first location, that first input that we've stored away, now say 9 in them. And we can test that program out. Go copy and paste it in and run that in our Excel workbook.